Nice finish on the machine. They actually deburred it.
It's a first.
Yeah. Top
See
of
what
the
he stamped.
15.
Yeah, he's in. Is he in metric?
No. That was
So
looks like you dressed in the front too.
nice.
So we're working on our 1980 911 SC engines back from the machine shop. We've had a run on SC engines this past few months. We've just gone through and I've retapped all of my head stud holes. Aluminum cases don't need time certs unless something is damaged, but it's not usually an issue with threads pulling up. We've done the oil leak modification where we use some Dow sealant to seal the metal part for the oil coolers. And we've cleaned out all of the oil galleries. Just because it's been back from the machine shop does not mean that it's ready to assemble. You got to clean and flush all of this out. I use brake cleaner solvent and a lot of compressed air. The plugs in the front have all been redone at the machine shop, and he's cleaned all of those passageways, so I don't need to get my oil galley brushes down there, and he's got new plugs installed. So this half of the case is done, ready to start playing with parts. Just getting all of our parts prepped for the case side of things. Set up. I've polished the front half of the crank already, and I'm just going to polish the back half. The initial measurement was perfect, right on standard across the board with plenty of material, but I'll measure it again after we've polished. In polishing, we're not looking at taking off a lot of material, so if we see like this journal here has been polished, as soon as I touch it, it leaves a mark, and this journal has not. It's still in really good shape. 3-liter cranks are really tough, and they usually hold up really well. Okay, so here's a crank. I just polished the seal area a little bit as well. And while it's still in the lathe, I'm going to grab my mic because it's going to be easy to measure it because it's all supported. And we'll recheck all our journal sizes and record them so we can do our bearing clearances. So as usual, first thing we do is set 0, 50.8 or 2 inches. And we're ready to go measure. Okay, D1 is 59.983. D2, 59.973. Rod Journal 5, 52.972. Rod Journal 6, 52.975. Also, all standard. All right, so we have our crank that is polished, everything cleaned out, flushed out multiple times. Everything's measured. We're still all well within stock standard tolerances for a new manufacturer. And as I said before, these cranks are really, really tough. Now, a lot of times after you polish them, you will see some very small marks in the crank. And this is normal because a bearing has been spinning around on there. These are not reasons to machine or have a crank ground to an undersize. As long as the crank is smooth to the touch and has no really aggressive markings in it, then it is pretty much good to go. Okay, so I've just gone through and measured all of my bearing thicknesses. Those of you that have seen a video before will know that this is how I set my bearing clearances. I take my crank pin, my bearing tunnel size, and my bearing thicknesses, and that allows me to calculate what the actual physical clearance is going to be. This set was really close, not much variations, and we are talking microns here, we're not talking big numbers. The thickest bearing was 2.490 and our thinnest bearing was 2.486, so that's a spread of about 0.004 of a millimeter. That's really, really small. But what I'm going to do now is just compare that. I have all of my crank pin sizes written down for the mains and the rods. I have all of my tunnel measurements written down. I'm just going to calculate out which bearing goes where, lay the crank in, and do a test fit with our intermediate shaft and see what our backlash is like. Okay, we're just going to sit our crank in and seat the thrust. So all we're doing when we do that is we are seating our thrust bearing. That feels good, nice and smooth.
Seat those thrusts.
Yeah, because it is super, super tight. Can't even get it to lay in there, lay close. Okay, let me put it back out. Okay, so we're just checking our intermediate shaft clearance, sitting at 0.04, which is inside the spec. .03, there it is. 0.04, one more spot. Whoops, a little big there. Our problem is this is a +1 gear to begin with. The only way to get another +1 gear is to buy a whole new intermediate shaft. We can't buy just the gear.
Let's pick a few more spots.
It's big there too. It is done.
That's pretty big.
That's 0.09. Oh well, it's going to be a phone call. Okay, so we've got a new intermediate gear, and one of the things is the replacement, or the only replacement gear that's available is a type 0 gear. And what the difference is, we have 0, we have -1 and +1. If we look at the crankcase here, this 1 right here on the crankcase indicates that it is a +1. If it had a negative and then a 1, it would be a -1. And what that is in reference to is differences or tolerances in the machining when the case was brand new, from the crankshaft center line to our intermediate shaft center line. Now the big problem is if it's not a 0, and most of the engines are, but there are some that are plus and some that are minus, is you have to buy the entire intermediate shaft. So you get a shaft, you get 2 gears and a new intermediate in a -1 or a +1, and that's about $1,500 versus a gear for around $280, $300. So huge difference there. Now, when we have our cases closed and honed, this component here is reamed again because the case halves have been brought together. So it's also closed the bore on this. And what we find is often that will change the relationship between the crank and the intermediate shaft. So sometimes you can check it before you have the machine work done, and then when you recheck it when it comes back, it can be tighter, in tolerance, or out of tolerance. So our original +1 gear, which is a larger gear anyway, was worn out. We had 0.1, which is well outside the factory range. The tolerance is 0.02 to 0.04. So I just put this in with 2 bolts for right now because I wanted to check it. And we are sitting right at 0.02 on the minimum tolerance. So the 0 gear now, which would have been too small on the original machining, having the case closed and honed back to standard, has actually brought the case into a tighter tolerance than it was from the factory. Now another quick check that you can do is rotating the crankshaft counterclockwise, or clockwise, sorry. If this gear starts to climb up and out of the case, this gear is too big. And that's a quick way, before you even put a dial gauge on it, put your intermediate shaft in, turn your crank by hand, and if this gear should not try to walk out at all. And usually I can feel that clearance. It's going to be very, very tight feeling. It's barely noticeable, but the dial gauge will show you that 0.02 to 0.04 backlash. Okay, first time using, oh, I see the torque coming up. I like how I can read it.
It's getting close.
Target 25.5. Nice.
Getting close.
25.1. Getting better. 25 even.
Are you feeling the differences?
I'm just watching it. 25.1. $25.3. Nice.
Is that on?
Says I've tightened 6 fasteners so far. You can see how many fasteners I tightened on the 911 engine job.
That'd be interesting.
I wonder if I just go seat it.
I'll do them all the same. 13.
Yeah, it starts again. So if I go
Yeah.
13.
Does it know that it's on a different one?
Well, it knows that the torque's different.
Mm.
Right. Certainly more accurate. 25.1.
Mm.
Great, feels nice and smooth, easy to rotate. Done. Pull our crank back out, get it back in our crank stand, and attach all of our rods. There's a little tiny nick on our distributor gear, which is pretty inconsequential, but we'll address it very lightly with a fire while it's out of the engine case. Okay, so we are getting our connecting rods all on. All of our rods have been cleaned, sized, new rod bolts, new bearings. Our bearings are matched to our journal sizes. And we also want to make sure numbers always match. Very important. New nuts as well. Seating the bearing, which is totally normal. We're just nipping it by hand. And now we're ready to torque. So we've got our new snap-on torque wrench. Full disclosure, no deals, paid for it. Snap-on is not sponsoring me, although if they're watching, they can. One of the things that I like about this is I was able to set up a preset, and it's set up, the torque is 50 to 55 Newton meters, so I was able to put that range in on the meter. Also, it tells me my count. So when I'm finished doing all of my connecting rods, right now I'm up to 7 of 12. So once I tighten this one, once I've completed both of these, it'll be 8 of 12, moving on to 9 of 12. One of the other things I like is I can bring it up. Say I want to go to 30, just to seat my rod bolts, seat my bearings, and it doesn't register it until it hits the magic numbers. And then we're going to bring it all the way up. 50.2, and that was 7 of 12. 50.4, and 8 of 12 display. Nice. Okay, bearings on. Okay, over here. Dowel pin installed. Locate the number 8, fresh oil in our bearings.
Oops, they're too loose and they drop down.
Everything's where it's supposed to be. And just locked into the dowel pin. A little bit of lubricant on the O-ring. And this half of the case is done. Okay, case is ready to close. O-rings installed on oil pump and oil return or oil feed line. Timing chain supported, rods supported. In our case, all bearings installed, intermediate shaft bearings installed, lubricated, and case has been 574. Okay, so we've just got all of our bolts in. We're just going to start nipping stuff down. Nothing's actually tight. The cases are on, but they haven't actually contacted yet. I'm not worried about that washer turning just yet, because until we get down to making some contact.
Squishing now.
What's up?
It's already squished a bit now.
Yep, but not completely.
No. So right now you're not doing the order.
No, because
You
I'm
just-
just nipping it down.
Yeah.
No actual torque.
It's quite a long ways because there's quite a lot of thread on everything.
Yep.
I could do these.
Right.
Oh, they're all on the nylons.
Okay, I'm going to hop on about this for a minute because I really like it. All right, what I've done is I've actually loaded my presets for the stuff that I'm always tightening. So connecting rods, case through bolts, and 25 Newton meter. In 25 Newton meters, I didn't put any amount of fasteners just because I'm always tightening and it doesn't really matter. In my 35 Newton meters, I have 14, which is there's 14 bolts. So we're going to go ahead and tighten everything down. Out of 14. See what so now 25. Negligible. Doesn't even read on the meter.
On what?
The running torque.
Oh,
Yeah, it's so easy to over torque on a low number.
build an engine.
Okay, we're just going to do our safety valve because it's right here. And then safety valve spring, new plug and washer.
There's no stick that goes down this one?
Not on this one, it's the bottom one.
Okay.
Okay, this is something where I found kind of interesting too, because it set it to 60 Newton meters,
Yeah.
kilograms per centimeter, 612.
D and yes.
Decky Newton meters,
Yeah, well it's just
which
by
is
10.
basically at a decimal point. But this is where you get the difference, because if you did the conversion, it would give you 44 foot-pounds. It's actually 44.3. When I looked at the 25 Newton meter, it's actually further away. You say 18 foot-pounds for 25 Newton meters, and really it's 18.6 foot-pounds. So doing it in the right scale is more important than people give.
But there's discrepancies between everything like Fahrenheit and Celsius.
Okay, it's one of these ones that sometimes can feel a little funky. Yeah, right there feels funky.
I feel like I want to give it its whole talk is what you're going to say.
50.
Yeah.
Yeah, I'm going to leave it. I'm at 56.4.
Yeah.
But I can feel the washer doing weird stuff, and I don't want to pull the thread. We've got new oil pressure control piston, the updated spring, updated plug, and guide sleeve.
Same talk?
Same torque. Trying a copper seal ring. on this one.
Okay, see if you can feel the difference.
It already feels better. Yeah, no problems. It's the aluminum that's failing.
Oh, it's balling up, I think. You going to replace it?
50.5. Yes, I'm going to replace it with copper. It's pinched in around it. And it's just crushing. I have to actually cut this off. Okay, so we're cleaning and prepping our cam boxes. I already pulled one apart and cleaned it. So to do that, we got to drill out our plugs. So I'm going to center pop it so I can drill it and tap it to remove it. Got a 5mm hole, and then I can use an M6x1 tap to tap and thread it so I can put my extractor in there. I'm just going to tap this, and I recommend doing this if you haven't tapped with a drill before. It's very easy to break a tap if you go sideways at all.
Oh, you got a new tool?
Nope. Had this tool for many, many years.
I just haven't seen you use it.
This is a pin extractor. Not actually used on Porsche. It's actually a Mercedes-Benz tool.
Nice.
Pulling out timing pins. It works great in this application. So you drop them down like that. Okay, there's our pins out. There's our oil spray bar out. Got a lot of debris from me drilling it at the ends. There's definitely some stuff down there. Very important to clean these out. These kind of are the last place that oil reaches in the motor, and they'll collect all kinds of garbage. So I'm ready to hit this with just a little bit of brake clean, get the last of the oil out, even though I've washed the whole thing, and then into a vapor blast machine, followed by a ceramic polisher, and then a bunch more work: scraping, dragging, cleaning. These cam boxes take the longest to clean. It's probably about 2 to 2.5 hours per box to go through, polish all of where my rockers sit, scrape everything, get all the remnants of the old sealant out. So there's just a lot of work on cam boxes. So this is a prime example right here. I was just flushing this line, and this particular engine did wipe out the cams, so we're putting a new set of cams in it, but this cam feed pipe here is 100% blocked. So something you've always got to pull out. You can see the difference. That's an open one versus a blocked one, where that one's just completely restricted versus what it looks like when it's open. So even blowing at this with some compressed air didn't do anything to get it out.
Get a drill.
I just pushed it out with my bearing scraper. But I could actually see it when I looked down the tube. Yeah, there's all kinds of debris down there. So we're going to have to get our brush down and brush that out because it's stuck to the sidewalls. Nice and clear down the tube. Sprays. Bottom spray. Bottom spray. So I'm just going to CC our cylinder. I mean, we've done the math as far as how much has been removed from the case and the cylinder heads, and we're just going to confirm our compression ratio. Usually on the CCing a standard SC head, Usually lands right around 89 cc's or thereabouts, depending on how much has been cut off of it. We're at 88.6, so pretty much right there. 87 cc's exactly. Okay, so I've done all my math on our piston pin heights, our shim packs, and my target compression ratio for this engine was 9.5 to 1. The calculated shim pack based on our dome volumes and our cylinder head cc's, our case machining, rod length, pin height on our piston, comes out that we need a 0.75 shim pack to achieve that 9.5 to 1. So I'm using a 0.5 millimeter copper shim. These are the shims that are now coming in the gasket sets. Should be a 0.25 shim. However, they're adding this coating to it, which is adding 0.06 to the total thickness. So when I measure the two together, we're coming in, let's get a better measurement, 0.82 of a millimeter. So it's a little, it's 0.07 of a millimeter higher than I want to. There's going to be a little bit of squash when everything's torqued down. So it shouldn't affect my compression ratio too much. I'll punch the numbers into my program just to confirm it though. Want to be for how much they cost. Okay, I've already set the circlip in on this side, and with these, the flat spot here faces the intake valve, and this is where your spark plug is going to live. Okay, for all of those of you who are scared, because these are open, wrist pin circlip installer alleviates those fears. If you're stuffing rags and other stuff in there because you're worried about dropping one, buy one of these. You won't ever drop one again. Just like magic, it is. Okay, circlip's turning. Circlip's turning. Use their grease and make sure it says top. Says top, and if we rotate, says top on the oil ring. If you could camera it.
Oh, I see. It's that ring.
The bottom ring.
That one.
Says top.
Oh yeah, it does. I can see it.
And I've already pulled a ring off and done a ring gap measurement, because just because it's pre-assembled doesn't mean it's right. So got to orientate.
You like to put them on the...
Like that.
Great.
Put my first pin in, because we can only get to one. Love that tool. Should buy one if you don't have one.
Steve will be happy.
Yes. Tell Steve that I sent you. Okay, seated. Well, when you turn them, if they're not in the groove,
They'll get in the groove.
See how that turned? Probably not, because you're on the wrong angle.
Yeah, I'm in your way.
They won't turn if they're not in the groove, because there'll be too much pressure on them. See how it moves? Awesome. Cleaned up and Cerakoted air guides. Got no rock, no low spots. Yep, I wasn't going to hop on about it.
But more accurate.
Way more accurate. But I feel like I got more leverage too.
One's a little bit bigger than your same size one for the drop.